Hello everyone, my name is SN Patil. In this video lecture, we will discuss numerical example on the gamma function. So here there are two numerical. First is evaluate and then second is show that. Okay, let us solve the example. We know the result of the gamma function. Gamma of n is 0 to infinity integration e to the power minus t raised to n minus 1 dt. Now I am simplify this result. Replace n by n plus 1. So here substitute n is equal to n plus 1, n plus 1. Okay. Then gamma of n plus 1, 0 to infinity e to the power minus t, and we substitute n equal to n plus 1. Plus 1 minus 1 cancel, t raised to n dt. Okay. For solving this numerical, the result is very helpful instead of the original result. Okay, now we have the problem evaluate. Then I means integration first 0 to infinity. Now I am writing the first exponential function, then algebraic function e to the power minus root x, x to the power 1 by 4. That is here. This is x raised to 1 by 4 with respect to x integration. Now in the formula, the power of exponential function having the linear variable is there, and here there is a root x is there. So we replace this by linear factor so that we use substitution. Suppose this is equation number 1. Put root x is equal to t. Okay. Now for finding the x, I am taking squaring both sides so that x is equal to t square. Okay. Therefore differential both sides, differential, then dx is equal to 2t dt. Now limit also change because we transfer x to the t. Therefore the limit for new variable, when the lower limit x equal to 0, then t is 0. Upper limit x is equal to infinity, then t, put x equal to infinity, then t is infinity. So equation 1, it can be written as I is equal to 0 to infinity limit for the new variable t e to the power minus t. Now the value of the x is t square, okay, raised to 1 by 4, and the value of the dx is 2t dt. Okay. Now here 2 is constant term. It can be written as 2 times 0 to infinity e to the power minus t. And here apply the property. We know the property a raised to m, a raised to m raised to n. Indices property, it can be written as a raised to mn. Okay, so it can be written as t to the power 2 means m, and this is n. That is 2 into 1 by 4. That is 2 by 4. That is t raised to 1 by 2, and this t dt. Okay, and see, we get 2 times 0 to infinity e to the power minus t, and t raised to, here 1 by 2, base is same, addition of indices 1 by 2, and here 1, that is 3 by 2 dt. Now we have the formula. We use this formula. Then I is equal to 2 times gamma of the power of the t is n. It can be written as gamma of n plus 1, where n is 3 by 2 plus 1. Okay, that is 2 times. And we know the one more result, the gamma of n plus 1. If n is not integer, then n into gamma n. That is, it can be written as 3 by 2 gamma of 3 by 2. Again, we write 3 by 2 as a n plus 1. It can be written as here 2, 3 by 2 gamma 1 by 2 plus 1. Now 2 into 3 by 2, apply the result same. Gamma of n plus 1 is n into gamma n is 1 by 2 gamma of 1 by 2. And we know gamma of 1 by 2 is root pi. That is 2, 3 by 2, 1 by 2, and the root of pi. 2 cancel. So we get I is equal to 3 by 2 into square root of pi. Okay. So that is the solution of the first problem. Now second problem, there is a show that the integral root x e to the power minus x square with respect to x integration is equal to root pi divided by the 3. Okay, let I is equal to integration 0 to infinity. Now I am writing first exponential function minus x raised to 3 root x with respect to x integration. So this is equation 1 in the second problem. This is second problem. This is first problem. Okay. Now we want the linear variable of the exponential, so that we use substitution. Put x cube is equal to t. Now here identify x for calculating the dx. So taking 1/3 power both side, that is x is equal to t raised to 1 by 3. Therefore, differential dx is equal to 1 by 3 t raised to 1 by 3 minus 1, that is minus 2 by 3 dt. Now limit there will be no change in limit because single variable in left and right hand. So put x equal to 0, we get t is equal to 0. X is equal to infinity, that is upper limit. So we get upper limit for t is infinity. So equation 1, it can be written as I is equal to 0 to infinity limit for t variable e to the power minus t. Okay. Now the value of the x is t raised to 1 by 3, and there is a root x. Root x means there is a variable raised to 1 by 2, that is root x. It can be written as x raised to 1 by 2. Okay, now the value of the dx is 1 by 3 t raised to minus 2 by 3 dt. Okay, now here 1 by 3 is constant term. 1 by 3 is constant term. 0 to infinity e to the power minus t. Now apply the indices property. See here, a raised to m raised to n, it can be written as a raised to mn. That is 1 by 3 into 1 by 2. Okay, that is t raised to 1 by 6. And here t raised to minus 2 by 3 dt. Okay, now here base is same. Addition of power, that is 1 by 6 minus 2 by 3. Okay, so simplify this term, that is 1 by 6. Here LCM is 6. LCM is 6 multiply and divide here 2, that is 1 minus 4 divided by 6. Okay, that is minus 3 by 6, that is minus 1 by 2. Okay, that is 1 by 3, 0 to infinity. Here we get minus 1 by 2 e to the power minus t raised to minus 1 by 2. Okay, t raised to minus 1 by 2 dt. Okay, now I is equal to 1 by 3, and we know, see, we get the standard format e raised to minus t raised to n. So here n is minus 1 by 2. So that is the result is gamma of n plus 1. That is gamma of minus 1 by 2 plus 1. That is 1 by 3. 1 by 3 and here minus 1 by 2 and plus 1. Simply gamma of 1 by 2. And we know gamma of 1 by 2 is root pi. So that we get here root pi. Okay. And divide by 3. So the required integration is 0 to infinity I is equal to root x e to the power minus x cube dx is equal to square root pi divided by 3. Okay. Thank you. Thanks for watching video.